Airplanes are one type of carbon fiber composite material used in today's technology. Some performance factors of airplanes is that they need to be able to transport, need to be aerodynamic, maintain their shape, be sturdy, be durable, and be weather resistant. The material properties of the airplane carbon fiber composites is that it needs to be resistive to strain, compression, and shear stresses applied to the plane. It needs to be resilient, have a good yield strength, and be a good price. There are four main forces that airplanes encounter when flying. One is thrust, lift, drag, and the weight of the airplane. When in flight, airplanes encounter various forces that cause different fields of stress to be displayed within those various aspects and locations of the airplane. Today, nearly 50% of airplanes are made of advanced composites, 20% aluminum, 15% titanium, 10% steel, and 5% of other materials. Carbon fiber is made by heating polyacrylonitrile that creates a hexagon shape and results in creating tubular structures of the carbon fiber structure. These images are SEM micrographs of transverse fracture of AC carbon fibers. This information can be used when trying to understand the material properties of carbon fiber when applied to the stresses that occur within the plane.
Unlike steel or aluminium, textile fiber materials can save weight simply by determining the direction of the acting external forces. The stability of the material can be affected by placing the stability-providing fibers appropriate to the direction that the external forces are acting on the structural part. For example, for parts stressed by torsion, that would be at 45 degrees to the length of the component. The basic material is carbon fiber. Each of these strips consists of about 600,000 filaments, 6 million threads per square meter.
After the carbon fiber fabric is made, they place it within a mold to create the shape of the wing or the body of the airplane. After the carbon fiber and the resin cure, there is an assembly line process that is used to build the full airplane that companies use the carbon fiber structure on. The assembly line process utilizes specialized workers that know the process of inserting specific locations of the plane in order to create the full plane with each individual mold that has been created with the carbon fiber molds. Given the unique property and structures of the carbon fibers, the processing does not affect the microstructure within those fabrics. Since carbon fiber is only strong in one direction, and knowing the stresses that apply on the plane, the layering of the fabrics over each of those locations during the processing and the assembly of the planes, it increases the strength and reduces the weight of the plane altogether. One process we learned in class that's similar to using molds and assembly of material is bronze sculpture work. The bronze sculpture work involves creating a mold and then creating a cast out of the mold, pouring the molten metal into that cast, and then assembling it and smoothing out the grooves between the pieces, which then create the whole piece that the material had originally been formed with. Other processes that could be used to make the carbon fiber airplane are layering of the fibers directly onto a harder mold of the airplane, The direct layering on a mold of the airplane has its benefits and drawbacks. One benefit is that it is faster and then it is already assembled and directly onto the mold. One drawback is that the process takes longer because it has to go little space by little space rather than having a full fabric that they can use and just place in the mold. Thank you for watching my video about carbon fiber composites on airplanes. I hope you enjoyed it. Now go watch someone else's video that's more fun and probably better.